Hey everyone, this is Derek, and this is going to be the first of 4 videos about rational functions. And so in this one, we're going to learn some of the defining features of the functions, and then we'll kind of look at graphing them and do inequalities again like we did in the last section. So there's a bit to figure out here. First couple things we're going to look at are going to be domain vertical asymptotes, which we'll call VAs, and horizontal asymptotes, which we'll probably call HAs, just because it's a mouthful to both say and it's a lot to write as well. So for the domain of a rational function, if you have something that's a fraction, a over b, b can't be 0 because we can't divide by 0. So anytime we have something with a denominator, we have to be careful not to have zeros in the denominator. And those are going to be the values that we're going to have to eliminate from the domain. What happens at those values is we get vertical asymptotes. So say I had some rational function like, x minus 3. So for this particular one, x couldn't equal 3 because 3 minus 3 would give me 0. And what that means is that x equals 3 on the graph, 1, 2, 3. We're going to have this weird behavior where one side does one thing and one side does another. And there's going to be this kind of funky break. There's another option that can happen. It's not going to happen in this class though. So we're only going to see the ones that do this kind of behavior. Horizontal asymptotes, that's another thing that can happen, and that's talking about what the function does on the end behavior. So the vertical asymptotes are going to kind of dictate what happens in the middle of the graph where things are diverging or going off together, what have you. The horizontal asymptotes are going to talk about the end behavior, so they're about what happens as you go out to negative infinity and infinity. And we're going to see 2 versions. And this is all really hard to read, so I'm just going to do a couple of simple examples over here and I'll make it clearer. So we have this, basically the leading terms. If I have something where I have x to the n over x to the m, that's kind of our deal, just to blow this up a little bit. If n is small and m is big, oops, that should be an x, my bad. So for instance, if I have x plus 2 over x squared plus 5. So the power up here is 1, the power down here is 2. So that's what I mean by small over big. That is always going to come out to y equals 0 for the horizontal asymptote. And the reason is, if you think about, if we put in a million plus 2 is pretty much a million. A million squared is really, really big, plus 5 doesn't matter. So these kind of reduce out, and then you have x over x squared, which becomes 1 over x. So then for large values of x, 1 divided by, a billion is really close to 0. So for large values of x, this thing is going to approach 0. And that's what the horizontal asymptotes do. So verticals, crazy stuff in the middle, horizontals, end behavior. And then our domain is going to go with the verticals. So let me show you some examples using those definitions. Oh, shoot, I forgot one. Sorry, down here we had if the exponents are the same. So say we had 3x squared plus 2 over 5x squared minus 1. So again, if x is a million, no one cares about the 2 and the 1. And then a million squared over a million squared is still 1. And so what it ends up reducing to is those coefficients. So in this case, our horizontal asymptote will be y equals 3/5. So it's the ratio of the leading terms when the powers are the same. It's y equals 0 when the numerator is small and the denominator is big. Okay, so let's see what that looks like with some examples. For this first one, find domain, vertical asymptotes, horizontal asymptotes. So here, our domain every time is just going to be whatever can't be in the denominator. So in this case, x cannot equal -7 because that would give me division by 0. Our vertical asymptotes are going to actually be the thing the domain can't be. So vertical asymptotes are going to be at x equals -7 because that's what's messing it up. And then for horizontal, this is small over big. This is like x to the 0 over x to the 1. And so anytime small over big, y equals 0. Same thing here. So domain, in this case, our denominator is a little bit more complicated. So let's get that factored. So we'll take an x out and get x squared plus 5x plus 6. And then multiplies to 6 and adds to 5 is going to be x plus 2 and x plus 3. So our domain is going to be not -3, -2, or 0. And then our vertical asymptotes are going to be x equals those same exact things. And then the x equals, remember, those are our vertical lines. When we have x equals, that's a vertical. When we have y equals, that's a horizontal. And so x equals -3, -2, 0 for our vertical asymptotes. And now our horizontal this time, so this one is x squared over x cubed, so that is still small over big. So that is still going to be y equals 0 for large values of x. Okay, so for this one, one thing they did was they kind of wrote the numerator in the opposite direction of the denominator. So I'm just going to rewrite that in descending order to make sure we're all looking at the same stuff. And then for our domain, this time, if you can look at that and know it's going to be -6/5, great. If not, here's just a reminder that we're going 5x plus 6 doesn't get to be 0. We're bringing the 6 over. I may have said positive when I said that, but should have said negative. And dividing that out. And then x can't be -6/5. And again, for the vertical, that makes it the x equals -6/5. And then here for the horizontal, that's the one that's a little bit different on this. So there's a little invisible 1 there. And then they're both x to the first. So again, if x is 1,000,000, -1,000,000 plus 1 is still pretty much -1,000,000. And then 5 times 1,000,000 plus 6 is still pretty much 5,000,000. So it all reduces down to that -1/5. So y equals -1/5. And then this example, same stuff, domain, x can't be -6. So vertical asymptote, x is -6. Horizontal asymptote, the too easy, it's hard. So these are both to the first. So remember, this has little invisible 1s out front. So y equals 1.